Ferrofluids, or magnetic fluids, consist of dispersed nanoscale particles which are coated with a surfactant to prevent the particles from clumping together. Ferrofluids will lose their induced magnetism when removed from an external magnetic field. So for this experiment, the nanoscale particles that are used are iron oxide, which is found in the ink toner. Their surfactant is the vegetable oil, and the external magnetic field is the rare earth magnets. So iron oxide is found in many laser printer toners, and that iron oxide helps the toner hold its magnetic charge on the printer's drum. Like, that's why there's iron oxide in laser printer toners. So for the experiment, I bought some laser printer toner, some vegetable oil, and a case of rare earth magnets. I could only find really small ones, but that is what I have. So the toner is a mix of suspended magnetic particles, which I then coated with the vegetable oil as the surfactant in order to prevent clumping and allow for fluidity to allow for a ferrofluid. I mixed about 50 milliliters of toner with 2 tablespoons or 30 milliliters of vegetable oil in a cup. I then mixed the two together and stirred until it was a thin liquid. Then I got my rare earth magnets out and attempted to manipulate the liquid using the external magnetic field. Unfortunately, my liquid did not act in the way that I expected or rather hoped. I'm sorry. I tried to change the concentrations of the toner and oil to see if I could fix the problem, because in the video he said, oh, maybe you need more vegetable oil if you used this amount of toner. So I added some more vegetable oil, tried to thin it out a little more. When that didn't work, I was like, okay, maybe I need a little more toner, so I added a little more toner. Unfortunately, I couldn't fix the problem. And I've been trying to figure out why exactly it failed. Honestly, I'm not sure. I used all of the required materials and I used them all in the amounts that were presented. I have one theory that's the toner itself didn't contain enough iron oxide, because I was reading that some contain more and less depending on what kind of laser printer they use. Another theory is because I only had like little small magnets, maybe they weren't strong enough. I'm gonna go ahead and try it so that you can see, and maybe we'll be lucky. So let's see. Let me get my earth magnets out. Maybe. Hold on. Okay. So here they are. I don't know if you can. Yeah, there you go. My hands are black, as you can see from messing with all of the toner. Okay, so it's kind of hard to see on the video. But yeah, my liquid is not like spiking or kind of reacting in any way. I tried it with just like one magnet at first, and then I tried it with the the whole stack, and it's just really not moving or becoming magnetized. So I had hoped for success, but unfortunately it was not able to reach that goal, so it's kind of disappointing. But anyhow, so despite my lack of magnetism, through my research and reading, I do understand the reason why ferrofluids act in the way that they do, at least for other people. So ferrofluids are colloidal suspensions of small magnetic particles in a fluid. So the magnetic particles present, like I said before, are iron oxide or magnetite. So magnetite is a naturally magnetic mineral that can be found in like a lot of different kinds of rocks. And ferrofluids are super paramagnetic, meaning they only behave magnetically when in the presence of a magnetic fluid. And when there's no external magnet nearby, the magnetite particles in the ferrofluid behave as normal metal particles in suspension. However, in the presence of a magnet, the particles become temporarily magnetized, forming structures within the fluid, causing the ferrofluid to act more as a solid and like spike up like it's supposed to. Then, with the removal of the magnetic field, the particles are demagnetized, and the ferrofluid acts as a liquid yet again. So, while reading about ferrofluids, I was finding out so much about like the purpose of them and why we first kind of tried to figure them out and mess with them and stuff. And it was really, really super interesting. And I found out that ferrofluids were invented to move liquids through space, which I just found really incredible. However, there's like so much that ferrofluids are useful for. They're used in rotary seals and hard drives. It's used in loudspeakers to dampen the vibrations. It can be used as a contrast agent for MRIs. There's possible research that it could be used to kind of push medicine to a certain part of the body, which is super interesting. So all in all, my experiment may have failed, but it was really interesting and intriguing to learn more about how ferrofluids work and the importance that they have in the world today, and the possible importance that they'll have in the future in like both scientific and technological fields and in the medical field. So thank you, and I hope you have a great week.